Well, doesn't that look like a right mess? G'day YouTube, JB from Oz here. And tonight, we're playing with a couple of bits and pieces. We've got a tool height setting gauge and we've got an MPG Pendant. Both of these are destined for the Sieg X3. Like anything, we've got a bit of RTFM to do. And I've managed to get a PC here, which I'm planning to connect up to this little gadget. It's a motion control NVCM4V2 and 125 kilohertz 4-axis USB Mark III card. Now, this surprisingly comes with a manual in English. It also happens to have on it a copy of Mark III installer and a license with that. So I don't know what the contractual arrangement is with Mark III as to whether that's actually a legitimate copy or not, but it'll be good enough for my testing. As far as this unit goes, there is a little bit of information which I've been able to find. This was on the Banggood website where I bought it, and we've got some English instructions there, blah blah blah, picture of it, as described. It has an armoured shielded cable. It also has a spot for a compressed air line to blow the tip clear, so there's an exit port and a compressed air line for such a fitting. And basically the go is that you have it wired up. You position on the end of your table, and then your coil can drop down, and assumedly once it reaches the money shot, boop. Now that actually showed a red light. I don't know if ours has got a red light, but we'll have to find out. But yeah, needless to say, without the English instructions, it's pretty hard to read what came with the unit. There is a pair of wires, the green and yellow, which are normally closed, and that's the signal that happens as soon as you touch it. And then the red and black is an over limit, which happens about 5 millimeters further down. So there is an initial touch and then a further down touch when you get to the point of overstretch. And I guess if your software is encoded for that, you could use both of those. So my first goal is to wire some power up to the controller and then see what we can see with this little sensor. Once we can see some software control from that, we'll then look at the MPG, see if we can get that reading. And then we start thinking about how we can wire all this up into the Sieg. These are the instructions as supplied in the box. And yeah, while it's hard to read, there is a really good unit option in terms of Google Translate in order to translate this. There's a tool measurement macro that's predefined, and the wiring, which is also in English on the Banggood website. So provided you've got the website up, you can sort it out. So the good thing about the Novusun NVCM motion controller is it is a USB connected device. And what that means is you're no longer required to have a parallel port. Comms over USB is usually a bit quicker as well. It has the step and direction pins. On this board it's showing actually as having for 6, so XYZ ABC. It's also then got a spindle voltage control, So you've got your 0 to 10 volts for VFD, or it also has the option for a digital position count, and it also has an output pin there for direction. On the input side of things, I'm planning to use pin 1 for our tool connection. Then you'll have end stops and so forth. You've got the option to plug in an MPG, an analog MPG, into this expansion port, and then you've got this DB15, maybe more than that, output ports, so you can fire relays off that and so forth. So first step, we're going to have, we've got power hooked in now. I've got my benchtop supply here that's going to supply us with 12 volts, and hopefully with the green signal and the yellow signal we'll be able to detect a touch off. Alright, so here we are looking at the diagram of the first header pin, which is our inputs 1, 2 and ground. So essentially what we've got is 12 volt through a floating resistor, which if we ground that, we'll have a signal to ground. So we'll have source here and sync to 6. Here we'll have source to pin 1 and sync to ground. So looking at that, we're going to have a source in yellow and sync as green. Okay, so just checking our wiring. We've got the yellow to pin input 1, red to input 2, and the green and the black to ground. Which means I'm expecting that when we very first touch, pin 1 will go, and then pin 2 will go when we get to over limit. They're basically normally closed 4 wires. So let's have a look in Mark 3 and see if we can see. We've actually got some progress now. So we've got our 12 volts in our plus and minus. We've got input 1 and input 2 connected to the yellow and the red on the tool height gauge. And then the black and the green, which is the earth return of those, are connected back to ground. In Mark 3, we've managed to configure under ports and pins, under input signals, probe, port 1, pin 1, e-stop, port 1, pin 2. Active high. Originally these were set active low according to the docs, but because these are a normally closed connection, when I first booted up it was telling me there was an error because they were being pulled low, which was triggering an e-stop situation. I've also managed to get my MPG Pendant hooked in, and that has a battery connection through to a USB over here. It happens to have a reset button on it, which if I press the reset, that's clearing the error code. Now if we look on here, as we contact our tool, you can see the digitize light comes on. That's coming on with the slightest touch on the tool, and if I overpress, it's actually getting to an e-stop state, which is triggering the emergency stop. So our e-stop pin and our digitize pin for our tool height setting are now wired up between the Novusun and the board, and our reset is now wired up on our pendant. That's now clearing again. So what do you reckon? Next we should hook some steppers up and see if we can get the pendant to wiggle the steppers. And I'm also curious to see if this is actually a 4-port or a 6-port, seeing as that all 6 ports have connectors wired onto it. It's got me curious. Alright, now for the moment of concern. We've got a stepper, 3 amp stepper and a 1-tie microstep driver. This particular controller has the pulse and the direction as a minus and a common positive. So the pulse is on the minus, which is red. The direction is on orange, which is minus, and then the brown is common positive, which we've gone to the positive on the pulse, positive direction and positive enable. And then the negative of the enable we've gone to ground, so we should have an enabled stepper. We've got a supply of power to the steppers, piggybacking off our 12 volt supply here. And then we've got our A, B, C, D, sorry, A plus and minus, B plus and minus for our stepper. Stepper's free to move at the moment, there's no power to the board. I've got a 30 milliamp current limiting mode, which if I turn that on, that has not done anything fancy yet. Now let's plug in our USB. I'm still not seeing any power over to this beastie, which means we're not enabled yet, possibly. Let's try reset. Nothing on C. Should we try it on A first or X? Let's try on X first. Alright, now anytime we're playing around with steppers we want to make sure that everything's turned off. So we're going to turn our power off. Going to disconnect USB and plug this one across into X. So power back on. We still don't have any power over here, which is a little bit concerning. Volts. Alright, a little more jiggery pokery. Turns out I need at least 18 volts for the stepper drive to actually power up. And then the enable pin is asking for 5 volts on each of these three inputs. Now, depending on the input voltage, I found another document that talks about using a buffering resistor in between to drop a 5 volt, 12 volt or 24 volt input into that. Now, as I've bumped the power up to 20 volts, I'm going to use a 2k ohm resistor. Didn't have a 2k ohm, so I wired two 4k ohms together to get my 2k. So I've actually got my enable driven off 20 volts with a couple of resistors in there to drop it down to 5 volts. Because enable's going to be on all the time, I wanted that to be the right voltage. I'm less worried about this. We'll see how we go. Probably should have something on there as well. Step and direction. Should only be pulsing when it needs to pulse. Let's see. Okay, we heard a noise. Our step is now active. Let's try reset. Don't risk it too much. Got it going the wrong way, don't I? Idiot. It's going straight to alarm for some reason. I'm going to measure the voltage, see if we can find it. Really? Would you like to say? So our spindle is currently off, and we've got 10 volts on VSO, which is the spindle output. Let me just put you down for a second. Spindle on, the voltage drops to 0, so 0 volts is our running. Which is good. Means 0 to 10 volt speed off the spindle of our Mark 4 is now also figured out. Good boy. Thank you for helping me. Alright, we might leave it there, I think. So, in summary, we've managed to get a pickup on our tool probe and over limit doing our reset. We've managed to get our pendant in line to reset. We've managed to get X and Y and Z adjustments, and also A. So it's 4-axis, which is good. We've got our spindle on, spindle off. Spindle on, spindle off, probe Z, work home, macro, feed minus, plus all the other bits and pieces to explore on this. So that's going to be fun. Reset, stop, start, cycle start button. Nothing to feed hold. Stop, line 0. So that's all looking good. Preset, haven't got any tools in there. Gonna have to get some tools in the tool library. This is all gonna be pretty cool. As I say, we'll call it there. We've got our 125 kilohertz 4-axis USB Mark III card wired in, detecting our tool height probe. We've got a spindle speed out, which means we'll be able to do Mark III controlled spindle speed from this device. Stepper motor drives. I still need to get some resistors in line, and I need to figure out what the story is with enable. If it doesn't need an enable signal, maybe we're gold. But yeah, the drawing doesn't show enable in this, which is curious. Yeah, so they only show that for the steppers. Don't know about the enable pin. See what I can find. More research.